In this video, we'll continue setting up our automation workflow architecture using modern tools. You'll learn how to run n8n inside a Docker container, connect it to a PostgreSQL database for storing and managing data, and use ngrok to securely expose your local environment to the internet. This setup is perfect for developers and automation enthusiasts who want a clean, containerized environment for their projects. But first, let's talk about PostgreSQL. PostgreSQL, or simply Postgres, is a powerful open-source relational database. It's widely used for storing structured data, running complex queries, and ensuring data integrity. In our setup, n8n will use PostgreSQL to save workflows, users, and execution history. By running Postgres in its own Docker container, we keep our architecture modular, secure, and easy to manage. Now, let's create our docker-compose file in versus code. Docker-compose is a tool that lets us define and run multi-container applications. Instead of typing long Docker run commands every time, we can describe our entire setup in a single YAML file. Inside this file, we declare services, like our PostgreSQL database and n8n, along with their configurations, ports, environment variables, and volumes. With just one command, docker-compose up, Docker will start all the containers we need, connect them in a network, and manage their lifecycle together. This makes our environment reproducible, easy to share, and much simpler to maintain, since all the details live inside one configuration file. Here's our docker-compose configuration. We start with version 3.8, which defines the syntax version docker-compose will use. Under services, we declare a container named Postgres. It uses the official Postgres version 15 image, and we give the container a custom name, n8n Postgres. The option restart, unless stopped, makes sure the container restarts automatically if it crashes, but won't restart if we stop it manually. Next, in environment, we set three important variables. Postgres_user defines the database username, Postgres_password sets the password, and Postgres_DB creates a default database for n8n to use. Finally, in ports, we map port 5432 from the container to port 5432 on our host machine. This means we can connect to the Postgres database both from n8n and from external tools like DBeaver. Now, let's start our container using docker-compose. The command is docker-compose f docker-compose YAML up d. Here's what it means. Docker-compose is the tool that reads our configuration file. The flag f docker-compose YAML tells it exactly which file to use. The command up starts all the services defined in that file, in our case, PostgreSQL. And the option D means detached mode, so the containers run in the background while we keep using the terminal. When we run this, Docker automatically pulls the Postgres image if it isn't already available, creates the container with the environment settings we defined, and connects it to the default network. In just one step, our Postgres database is up and running. Now let's check Docker Desktop. Here we can see our Postgres container running. Notice that port 5432 is exposed. This means our database is accessible on that port, both for n8n and for external tools like DBeaver. Now, let's connect to our Postgres database using DBeaver. We enter the host as localhost, the port as 5432, and use the username, password, and database we defined in our docker-compose file. After clicking Test Connection, DBeaver confirms that everything is working and our containerized database is ready to use. Great work! In this video, we created a PostgreSQL container using docker-compose, verified it in Docker Desktop, and connected to it through DBeaver. This gives us a solid database foundation for our automation workflows. In the next video, we'll bring n8n to life by creating its container and linking it with Postgres. Stay tuned, the fun is just getting started.